today's content. Let me know if you think of anything else, questions or issues with Canvas or anything like that. So prenatal development will be covered in that documentary that's on Canvas. So we're jumping straight into infancy here in lecture. So you can just make sure you watch that documentary. So today we're probably going to cover all the stuff on infancy and toddlerhood. I have things kind of split up in PowerPoint where we'll always talk about physical and cognitive development first, and then we'll talk about social and emotional development. We'll just kind of see how much time it takes us, but I think we should be able to cover both of those today. So some of the things you'll notice, these are things that you might already know if you've spent literally any time around a baby ever. First of all, they have some pretty explosive, dramatic growth that they go through in the first couple of years. So we're going to talk quite a bit about that very extreme physical growth. During this time, the brain is also growing just as explosively as the rest of the body, which allows for all kinds of advances in cognition during these first. We're talking here about the first 2 years of life, basically, so from birth until about age 2 or so. So this chart lays out kind of the typical average sizes of babies during this time. So you can kind of see that very explosive growth that they go through. In general, when a newborn is born, they're about 20 inches long. By the end of year 2, they'll be up to about 36 inches. So they would have gained about 75% of length from birth until the end of those 2 years. And their weight typically will about quadruple within those first 2 years. So usually when they're born, it's around 7.5 pounds or so. And then by the end of 2 years, they're up to usually about 30 pounds. All those obviously are averages. It's another kind of caveat I want to put on everything that I say in this class. All the stuff we talk about are generalizations. And so if I ever say anything and you feel like you're an exception to that, you probably are, because there's all kinds of exceptions to all the general things that we talk about. So obviously there's a huge range of sizes and weights and stuff that babies can be born, and they can grow at different rates. So these are just averages.
Mine were 9.5 pounds.
Oh my gosh, that's too much. Yeah. I think mine was 7 pounds, exactly.
I always feel weird when I hold normal size babies.
Right.
Mine were never this small.
Yeah, yours were just big from the beginning.
Yeah.
Yeah, that's too much. So in general, during these first 2 years, they will grow in a very specific sort of pattern. So there's these trends called the cephalocaudal trend and the proximodistal trend. Cephalocaudal trend refers to the fact that their heads will grow sooner and faster than the rest of their bodies. So if you look at, toddlers and infants, their proportions are always a little bit strange, where they have these really large heads compared to the rest of them. The proximodistal trend refers to the fact that sort of the internal trunk of the body usually grows faster than the outer limbs. So again, those proportions in a toddler can look a little bit strange compared to an adult. They might have, short, stubby little legs and arms compared to the rest of their body. So that's kind of the normal pattern of growth that most infants and toddlers will go through. There are several factors that influence how much a child is going to grow during these first 2 years, but most of those factors can be broken down to these two categories, either heredity or their nutrition. So there's a very, very strong genetic influence on height in particular. Height is about 80% heritable, which means that, 80% of the variability in height comes down to the genes that a person gets. So that's one of the highest heritability ratings that you'll ever hear of any trait in this class is height. It's hugely genetically determined. But then in addition to that, nutrition plays a really big role. So even if a child gets the genes to grow really tall, if they have some malnourishment going on in childhood, then they're never going to reach that potential full height that they could have if they got proper nutrition in those first couple of years. In general, whenever it's possible, whenever it's available and accessible, breastfeeding is going to be the best option for nutrition in the first year and a half or so of life. Most health agencies recommend first year and a half, especially the first year, should be mostly just breastfeeding is the main source of nutrition for newborns. Breastfeeding has all kinds of benefits. So first, it's very nutritionally balanced. It's going to have the right portion of proteins and fats and everything that the baby needs. There's also some evidence that breastfeeding can increase the bond between mother and child. to some extent. And then the other big benefit of breastfeeding is that the mother can actually pass on immunity through the breast milk. So if like the mom has developed, immunity to flu or COVID or something like that, those antigens, antibodies can pass through the breast milk and be passed on to the child. So that helps increase their immunity, which obviously is a good thing overall. There was a period of time, probably like the 80s, where doctors were actually recommending using formula and stuff because we just didn't have as much understanding at that point about how important breastfeeding actually is and can be. Obviously, though, there are lots of people who are in situations where they can't breastfeed for whatever reason. Sometimes women don't express enough milk due to various factors, or there might just be other situations where they're just not able to. Let me just make sure I'm not skipping anything here. There is some risk of overfeeding even at this very early age. And there's lots of good research that shows that the earlier there's like issues with weight, the harder it's going to be to drop that weight later on. So even, very early on, there needs to be some attention paid to not overfeeding and to also avoiding things that are like high in fat and sugar, etc. Most children around probably like a year and a half are going to start transitioning at least into solid foods. So you might start introducing like baby foods like pureed fruits and things like that. So by the time they get to toddlerhood, they're probably eating solid foods. So it's really important, especially then. It's not as much of a worry with breast milk and formula, but once you start transitioning to those, baby foods and solid foods, you want to make sure you're avoiding sugary foods, fatty foods, greasy foods, things like that, because that can contribute to obesity then and later on and all kinds of other health issues as well. So as the body is growing during these first 2 years, the brain is also undergoing some very, exponential large growth. Growth happens in a couple of ways. So one is that the infant will actually continue to make new neurons during these first couple of years of life, but more so they will create new synapses. So that's the connections between the neurons will grow and increase during these first 2 years. And you actually get to the peak number of synapses that you will ever have around age 2. So by age 2, this process of creating new synapses starts to kind of plateau and then actually starts to go in the opposite direction. So you start to actually lose some synapses after those first 2 years. So this process is sometimes referred to as synaptic pruning. And this actually happens through, there's this process called apoptosis. I can put that on the board. Apoptosis. I've heard some people pronounce it apoptosis, like the second P is sometimes silent. Either way is acceptable. But apoptosis is this actually, it's like a genetically programmed cell death process that neurons in particular are sort of programmed to undergo. So basically, if the neuron or the synapse is not being utilized, then it just is supposed to die by default, essentially, through this process of apoptosis, where it just kind of like digests itself, basically. The cells will undergo this process basically if they're not being used, which maybe intuitively seems kind of strange. Like, why would you, because this is like evolved to happen. This is the natural thing that happens in all toddlers as they get around this age. But essentially, this is actually really beneficial because all those extra synapses that aren't being used, they use up a lot of resources. They use up oxygen and glucose and all the stuff that's in your brain keeping it alive. And so if they're not being utilized, it makes sense, like, let's get rid of them because then we can devote those resources to other synapses that actually are being used. We'll talk in a second about language development, and I'll kind of come back to this idea of synaptic pruning so you can see kind of, like a real world application of why it's important. So just kind of keep that in the back of your head. So we're growing new neurons, new synapses, also getting rid of synapses that aren't being used. In addition to that, the brain is constantly undergoing this process called myelination, which is where the axons of the neuron are being wrapped in this substance called myelin. So myelin is this sort of fatty sheet that wraps around the neurons that basically makes them process faster. It's kind of like insulation or coating on like a wire is kind of what you can think of it as. And this myelination process will not complete until you're in like your early 20s. So this is something that, it starts prenatally. It's happening a little bit in the womb, and then it continues throughout toddlerhood and then throughout most of the rest of your life up until young adulthood. The other part of the thing that's happening in the brain is a process called lateralization. Lateralization refers to this idea that the two hemispheres of your brain kind of take on different tasks. So sometimes you guys might hear the concept of like right-brained or left-brained. The idea that a person is right-brained or left-brained is mostly BS, but there is merit. Like the idea comes from a kernel of truth, and that kernel of truth is that your brain does split up different processes to be in the right or the left. So for example, most of like your language abilities are housed in the left side of the brain. So whenever you're speaking or reading or doing anything that involves language, you get lots of activity in the left hemisphere, not so much in the right. When infants are first born, though, they don't have that lateralization. Their brains are kind of just firing almost randomly at just about anything. So over the first 2 years, you'll start to see that lateralization where different parts of the brain start to take on different tasks or different jobs. And that helps the brain basically function more efficiently overall. A lot of this growth of the brain is important. It's influenced by what's called sensitive periods. So sensitive periods, there's also sometimes called critical periods. That means about the same thing. A critical period or a sensitive period, it's a time window where you have to be exposed to certain stimuli in order to develop properly. So it's really important, for example, that infants in this stage are exposed to lots of visual stimuli. So if you look at like little infants' toys, oftentimes they're designed taking this into account. So often their toys will have like high contrast, like black and white checkers or stripes or black and white spots. They'll be very colorful, all the different colors of the rainbow. And it's important that the children get exposed to that range of visual stimuli because if they're not exposed to it early on, then they will have issues processing visual stimulation later. So it could lead to things like astigmatism, for example, where you are, you can't see certain orientations correctly. It's more blurry at certain orientations. So exposure to lots of enriching engagement during this time is really important. So the sensitive periods are not just true for vision, it's also true for pretty much everything you can think of. Like language, for example. We really need to be exposed to language frequently, consistently during the first 8-ish years of life in order to develop the ability to speak that language fluently. Okay, I'm trying to remember. I usually have a little note to myself about what videos are about. I'm pretty sure this is talking about the growth of synapses and how they connect in this apoptosis process. So we'll watch that. If it turns out it's something totally different, then I'll highlight the things that I thought were important. I also should have checked my volume. Let's see.
A piece of the brain the size of a grain of rice contains about 10,000 nerve cells, just in that little piece. You can just imagine how many pieces you have in your head. Within that 10,000 nerve cells, each nerve cell can make anywhere between 1 to 10,000 connections with other nerve cells. So there are something like 1 trillion connections.
It's almost overwhelming to think about the whole thing. If you think about how the whole brain and nervous system gets assembled, you just want to throw up your hands and say it's way too complicated, we're never going to understand it. The brain is the seat of our consciousness, of who we are. And in understanding where it comes from, we understand where we come from.
By 24 weeks, the vital organs of the fetus are well formed. The primitive heart can beat on its own. The once powerless lungs are now prepared to fill with air. And the brain has nearly its full complement of billions and billions of neurons, reaching out to each other, building connections with mind-boggling speed, nearly 2 million every second, until the brain has become a tightly packed network of trillions of crisscrossing wires, with more connections than stars in the sky.
you can imagine the size of the wiring problem. So how is that problem solved? How is that achieved during development? How is it that each one of those trillion connections is made appropriately?
You might think, oh, what a mess. It's just going to be a jumble of connections and wires all over the place. But in fact, the nervous system seems to have a strategy.
The strategy is in the genes. The brain begins to wire itself by following a precisely specified genetic blueprint.
The connections are following very defined rules. You know, go out of the eye, turn right at the optic chiasm, cross the chiasm, head toward the lateral geniculate nucleus, grow into the lateral geniculate nucleus. Don't grow into the medial geniculate nucleus because that's an auditory structure. So you can imagine the first stage of brain wiring is kind of like solving the problem of connecting phones in New York to phones in Boston. Making sure that you're making connections between Boston and New York and not Boston and Washington, D.C. And that's all specified genetically. Now then there's a second phase of brain wiring. Let's say you want to place a phone call to your grandmother in New York. And you want that phone to ring, you know, on Park Avenue and 47th or whatever. And you don't want the phone to ring up at the Waldorf Astoria. Okay, how do you get that precise phone to ring? That's the second phase of brain wiring. If you place a phone call to your grandmother early in development, her phone will ring. But so will a lot of other phones. So there are a lot of connections that are made. If the connections are correct and being used, they get strengthened. If they're not being used, or they're only being used occasionally, they're lost. We could call it use it or lose it.
Okay, so that just kind of summarized what I was talking about with this whole apoptosis and synaptic pruning period. Just kind of want to emphasize, so she talked about how that first phase is driven mostly by genetics. That's all happening in prenatal development. And then the second phase that she's talking about, where you use it or lose it, that's more driven by your actual experience and those sensitive periods. So that's what I'm kind of talking about. If you're not exposed to lots of stimulation in those first couple of years, then you're more likely to lose some of the neurons that you maybe actually need. Last thing I'll kind of say about the brain at this time, sort of related to all this, is that it's still very plastic and very malleable and adaptable. So if there's some sort of damage to the brain early on or something like that, the brain is much more likely to be able to compensate and fix that early compared to later in life. So there's still a lot of adaptability during these first couple of years. Okay, we might circle back to some of that when we talk more about cognitive development. That's highly related to brain development, so some of those concepts might come back up. Another thing that changes pretty dramatically during the first 2 years of life is the sleep-wake cycle. So again, if any of you have ever been around infants, you probably have experienced this. I have friends who just had a baby like a month ago, and I'm assuming they're basically just going to disappear for the next 3 years. But definitely the past month, I've barely talked to them because they're raising a child, which is a lot of work, and they never sleep. So initially, whenever a child is first born, they start out sleeping about 18 hours a day total. But that sleep is broken up into lots of very small naps, and waking up in between. So they're sleeping a huge portion of the day, but they rarely, I would say they sleep maybe at most like an hour or two at a time. And then they're going to wake up and they're going to want food and a clean diaper and all that stuff, and then they'll go back to sleep again. So then they gradually shift to a more regular day-night schedule over the course of the first 2-ish years or so. So usually by toddlerhood, by around the end of year 2, they're on a much more normal sleep cycle. They still often are going to be sleeping a lot more than you will in adulthood. I don't think I have the numbers here, but toddlers are still probably sleeping maybe 12 hours a day or so. But they're going to sleep a big chunk of that during the night, like we all normally do. And then they also might take a nap during the day in toddlerhood. So there's a lot of things that drive the changes in the sleep-wake cycle. Part of it is due to brain development. So some of the areas in the brain that regulate our sleep-wake cycle are developing throughout this time. And so once they get sort of more cemented and concrete, then that sleep-wake cycle has a lot better rhythm to it. They also have changes in melatonin secretion. So melatonin, is something that sort of builds up throughout the day. I'm thinking of something else. Melatonin is basically triggered whenever it starts to get dark out. So as it gets dark out, your brain sort of senses that darkness and then starts to release melatonin, which tells you that you're sleepy. And so toddlers start to have more of that regular melatonin secretion in dark compared to infants. Yeah.
I've known a lot of people who gave their little kids and sometimes toddlers melatonin supplements, and I heard somewhere that can disrupt their ability to produce it later on. Is there any merit to that?
I would guess, yeah. Again, that's one of those things, like, I haven't read about it in detail enough to say with certainty, but again, it's something that logically makes sense, because I know even in adulthood, you can develop a tolerance to melatonin very quickly. And it does, like, if you're taking it externally, then your brain basically learns, like, I don't need to produce this because it's being provided to me. So I would feel like if you're doing that really early on, then there's probably even a greater chance that you're going to adapt to not needing to produce melatonin. So yeah, that wouldn't surprise me at all. Yes. So it's driven by some of these biological things like brain development and melatonin secretion, then also just cultural factors and the needs of the parents. Obviously, like, most parents are going to have some sort of schedule. They have a job or other things that they need to be doing. And so they're often encouraging, trying to coax the infant to follow a more normal sleep-wake cycle because it's more convenient for everybody, basically. Another biological thing I should include here, too, is that just the fact that the infant grows makes it so that they can sleep longer because their stomach gets bigger and they can hold more food. If you think of, like, a teeny tiny infant, their stomach is, like, tiny. So, whenever they drink breast milk or whatever, they hold a small amount of that, and they're very quickly going to then secrete that. So they're going to the bathroom more frequently. And then they also get hungry more frequently because they're depleting that very small amount of food, right? So as you grow, you can hold more food, you can hold your bladder and stuff around toddlerhood. So that also increases the amount of time that they can stay asleep. And yes. All right, so some other developments that are happening, we're moving kind of more out of the biological realm and into, like, cognitive things that are changing. So there are changes in motor development. So they're working on their ability to do things with their hands and their feet and walk, etc. Gross motor skills are skills that require, like, the entire body to engage in, basically. So things like walking, crawling, jumping, those kind of big, large movements. Typically, they will develop these skills in a kind of predictable order for the most part. So most infants, they will first learn to support their neck. So, when a newborn is first born, you really got to hold them, like, giving them lots of support because they can't hold their own head up. So that's kind of step one, is just developing those neck muscles, being able to lift their own head. Eventually, that'll kind of evolve to where they can sit up on their own without any support. Usually then that will translate into being able to crawl. So once they can sit up, they also can then sort of move forward to get into a crawling position. Sometimes that also can happen from the stomach, like they can learn to roll over and then push themselves up. So crawling would be the next thing after sitting up usually. Then typically they're going to be able to pull themselves up with support structures, like they might use a table or a couch or a chair or something to pull themselves up so they're standing. So at that stage, they can't quite stand on their own, usually because of balance issues. So they might have, like, the muscles in the legs to support them, but if they let go of the couch, they're going to fall over. So then the next step after that would be taking their first steps. So typically those gross motor skills kind of develop in that very predictable step-by-step pattern. Fine motor skills would be things usually that are involving, like, intricate movements with the fingers. You could also maybe count, like, things you're doing with your toes as fine motor skills, but that would be things like grasping. That's one of the first fine motor skills they're going to figure out, just how to reach out and grab something and hold it and pull it towards themselves. Things like drawing and writing and scribbling, being able just to hold a pencil to begin with is a fine motor skill they're working on developing. Even things I would say like pat a cake, like doing things with your hands or whatever, those all would also be considered fine motor skills. Scaffolding just refers to kind of the idea I was talking about with the gross motor skills, that often they're like building skills on top of each other. So once they learn one skill, then that sort of opens the door to other things that they can build on top of that. And so again, maybe another point I want to make here is that it's very important that children in these first 2 years have lots of opportunities to practice these skills. So part of that is providing things like toys and stuff that they can grab, things with lots of different textures. I've seen like toys are really good if they have like buttons that they can button and snap, or zippers and things that they can sort of practice those fine motor skills with. So yeah, just giving them lots of encouragement and opportunity to practice these skills is super duper important. Oh, kind of a fun statistic I have in my notes is that on average, toddlers practice walking about 6 hours a day, and they fall about 17 times per hour. Yeah, so that's a lot of falling. They tend to be much more resilient at this age, like the bones are not solidified quite as much, and they have more padding and stuff, so they're less likely to be injured from a fall at this age compared to later. All right, there's also all kinds of developments happening in their sensory system. So things like vision and hearing, smell, taste, touch, all of that is also developing during these first 2 years. When a baby is first born, the world is kind of just like a confusing, jumbled mess, basically. So, the perceptual world to an infant, probably everything is a little bit blurry. They probably can't quite figure out where one object ends and another begins, and sounds are probably just like a jumbled mess that they can't quite make sense of. So they're going to develop those sensory systems over the course of the first year or so. So around 4 to 7 months, they start to have a sense of musical parsing. So they can kind of figure out like how they start to have preferences really for songs that follow the predictable pattern. So there's studies where they have, let me maybe back up a little bit and talk about how we even do studies like this with small infants, because obviously they can't talk at this age, so it's not like they can tell you, I like that song more than that one or whatever. But we can kind of measure babies' preferences by just their attention. So typically if you give an infant something new that they've never experienced before, they're going to stare at it, they're going to want to play with it, they're going to be very attentive to this new thing that they're interested in. And then as they get bored of stuff or there's something they don't prefer, then they disengage that attention. They'll look away, they'll stop paying attention. So we can kind of use that as a marker of like how they prefer different stimuli. So using that kind of setup, they've done studies where they play music that's like kind of normal parsing, that has like pauses where you would expect pauses to occur in music. And then they played other songs that are kind of like the same instruments, same sound, but the rhythm is all messed up, or there's pauses in weird places, things like that. And they find that around 4 to 7 months, infants start to develop a preference for the more normal sounding music that has pauses where you would expect them to be. And then, all of these are just sort of saying that all of that starts to get more and more complex as they go on. So they start to figure out like different rhythmic patterns. They might start to notice like songs that have, like beats in certain places or emphasis on certain beats. We're going to talk about this quite a bit more soon whenever we talk about language. But also around this time, they're starting to absorb a lot. So even though they can't speak yet, there's lots of evidence that they're absorbing a lot of information about the language that they're being exposed to. So one of the things they can do from 6 to 8 months is they start to really focus in on the sounds that are used in their native language. Again, we'll talk about that more in just a second, so that'll make more sense later. 6 to 12 months, they can detect sound regularities in human speech. So like in whatever language, in English, for example, there's certain sounds that are more likely to go together than others. Like there's, certain letter pairings that show up really frequently, other letter pairings that never show up. So they can start to detect some of those patterns in speech around 6 to 12 months. And then around 7 to 9 months, they can start to sort of figure out word-like units of speech. Again, we'll talk about language. This is mostly like how they're hearing language. We'll talk more about how they produce language in just a second. But all of that is just to say their hearing is developing, getting more precise, more complex. Same thing with visual development as well. So again, when an infant is first born, their world is this very confusing, blurry mess. When they're first born, their acuity is very low. Acuity is like how, how precisely you can see detailed things. Like when you go to the eye doctor, and get the like 20/20 or whatever, that's measuring your acuity. So an infant's acuity is about 20/80 at 6 months. 20/80, that refers to, so like whenever they're looking at something 20 feet away, it looks like what it would look like 80 feet away to most people. That's what that number 20/80 means. So their acuity is very low. Everything's really blurry, low resolution. That develops until, by about 4 years old, as long as they don't have any sort of visual problem, then they'll develop to the normal 20/20 vision. So that acuity gets better. Their sense of color, their ability to tell different colors apart improves over this first year or so. Around 6 months, they develop the ability to scan or track an object with their eyes. So if you take like a toy and move it around in front of their face, their eyes will track where that toy is going. Their depth perception also improves around like 5 to 7 months. They get sort of more sensitive to different depth cues. Some of you may have seen, there's like this study that they sometimes do with infants where they put them on this table that has like one side of the table is like checkers, and then the other side is clear, like glass or plastic or something, but the checker pattern continues on the floor underneath. And so if they have really bad depth perception, which they do early on, then they basically like don't see the glass. They don't see that the table drops off. They think that it just continues because they see like the checker pattern below. But as their depth perception gets better, they can sense that like there's an edge to the table and they shouldn't go any further forward. So they stop at that edge. So their depth perception gets more precise up to about like 5 to 7 months. They also develop better ability to recognize patterns, particularly faces. So really early on, they actually can recognize their caregiver's face fairly early. They often have a preference for their caregiver's face pretty early in development. They also can start to detect facial expressions, so they can tell whenever someone is sad or upset or happy. By probably about like 6 months is when that facial expression ability starts to really develop. Another sensory thing that's developing is what's called intermodal perception. That's basically the ability to kind of bind all these various sensory experiences into one coherent experience. So like all of you can, see me and hear my voice, and you know that both those, the visual stimuli and the auditory stimuli is coming from the same thing, from the same place. Like the sound is me and the visual part is me. Infants, when they're first born, they don't have that. They don't really piece things together as being like whole coherent units. It's just kind of like there's blurry visual stuff and there's sounds everywhere, and they don't really understand how that goes together. So during the first year, they're also developing that intermodal ability where they can figure out that the source of sounds and vision and all this other stuff is coming from the same place. Okay, so now let's shift to talk a little bit about some of the developments that are happening in cognition. So that would be areas like memory and language and their learning abilities, etc. So learning during a lot of life, but especially these first few years, usually takes place through different types of conditioning, which hopefully I know all of you who took Psych 100 with me would have learned about this. Hopefully all of you have learned about this in some other place if you didn't take it with me. But classical conditioning is basically where you're just making passive associations between different stimuli. Classic examples like Pavlov with the bell and the salivating at the food, that kind of thing. Operant conditioning is similar, but it's a little bit more active. It's where the organism, the person in this case, has to act in order to form the association. Operant conditioning happens through reward and punishment. So basically the idea is like if you want someone to repeat a behavior in the future, then you reward that behavior. If you don't want them to repeat that behavior, then you punish that behavior. And through operant conditioning, they will learn to change their behavior, basically. Children also learn a lot through modeling. I think I talked about this before, but yeah, so they will mimic the things that their caregivers and their siblings and the people around them do. especially if they see those things being rewarded. So modeling is another very important learning approach. In addition to being able to learn through all these processes, infants in the first couple of years are having improvements in all the things I have listed there. So their attention span improves. Initially, they get bored very quickly and very easily by things. You know, as they get older, they can sort of maintain attention for longer. Their memory also improves. So they can, you know, hold things in memory for longer. They can store more things in memory at a time. Executive function refers mostly to our ability to like monitor and control our own behaviors. So that would be things like planning and following goals, controlling and regulating our emotions, you know, acting appropriately in lots of different contexts and situations. That all fits under executive function. So that starts out very poor. I would guess that most of us would assume it's not okay to just like poop your pants in public, right? But a 6-month-old, totally fine with that. That's completely appropriate for a 6-month-old to do. So, you know, that all improves over the first 2 years or so. So another thing about memory that you all probably know, either from experience or something you've learned about, is infantile amnesia. So most of us don't really start forming memories that will, you know, that will carry with us long term until about 3 or 4. So if you try to think about like your earliest memory that you can remember from your own life, for most of you, that's probably going to be around age 3 or 4 or so. Yeah, go ahead.
I watched a documentary a long time ago, and it had a man in it, I can't remember his name, but he was talking about emotional memory sticking with babies, and it's not like a memory that we can recall specifically with all of our senses. It's more like, I think he was talking about the cry it out method and how it leaves an emotional memory on babies. But
yes.
I think at the time it was still like a theory. It wasn't really like an accepted.
Right. Yeah. Yeah. Well, I'm glad you brought that up though, because infantile amnesia is referring to a really specific type of memory that I would call episodic memory. So episodic memory is where you're like remembering something that happened to yourself from your own perspective, right? And so when I'm talking about infantile amnesia, that's what I'm talking about. We don't really have episodic memories until 3 or 4. But you're totally right that we have all kinds of other memories that we're forming in those first couple of years that they're not like that. They're not an episodic memory where I can remember this thing happened to me when I was 6 months old. But that thing that happened to me when I was 6 months old is still for sure going to impact how I develop later. Is going to affect me in all kinds of, you know, unconscious ways mostly. Yeah.
Yeah, I think it's really cool. Like my little sister, when she was a baby,
the way that they develop later on. So yeah, so infantile amnesia really just refers to episodic memories. You don't really start developing them until around 3 or 4. There's a couple theories about why. One of them is that we don't really have a good grasp of language until around that time, around like 3. I mean, most people will start talking before then, but you're not really putting together full sentences and stuff until around 3 or 4. And so one idea is that maybe we need language in order to encode those episodic memories. And so until you get language, you're not going to get those episodic memories. Another kind of similar theory is this idea that we need like a self-concept to attach these episodic memories to, and that during the first 3 years or so, we don't really have that self-concept. Like we don't necessarily see ourselves as like this separate thing that has an identity that's separate from everyone else. Yeah.
you mentioned like language types and memories. What about kids who are like born, like people who are born deaf and stuff?
Yeah.
Is it the same with science?
Yes. Yeah, basically. There's a lot of evidence that pretty much everything I say about language, verbal language, applies for the most part to sign language with deaf children. Yeah. One way of looking at cognitive development, or one theory that really focused on this, was Piaget's cognitive development theory. I mentioned this very briefly on like the first day or whenever it was when we were talking about important theories. According to Piaget, during this time, infants are in what's called the sensorimotor stage. And it's kind of all in the name. The idea is that during these first couple of years, the things that you're building are your sensory systems, your ability to just perceive the world and understand visually and auditorily what's happening in your environment. And then also motor abilities, that, your ability to sense things tactilely, to be able to feel and grasp and touch, and then develop those gross and fine motor skills that we talked about before. So according to Piaget, that's really the focus during these first 2 years, like conscious self-awareness. So a lot of this like building sensory and motor information comes through exploration, kind of like I was talking about before. You really need to make sure they have lots of opportunities to explore. Piaget also talked about this idea of circular reactions. Again, something you might have seen in infants if you've been around them. They often are just sort of making these like random spasmodic movements with their body, and they don't have a ton of control over that to start. But oftentimes what might happen is just through sheer accident, they kind of stumble upon some motion. So maybe they're kicking around in their crib and they accidentally like reach out and hit their mobile thing that's floating above them. And then they realize like, oh, if I make that movement, I can touch this thing. And then if I touch it, I can grasp it. So those circular reactions kind of help the child develop almost through accident these different kind of motor abilities and motor skills. Another kind of like marker of this sensory motor stage, kind of the end of the sensory motor stage, is the development of object permanence. So a lot of like small infants, they do not have object permanence. So if you have like a toy or something that you're showing them and then you hide it, to them it's basically like that toy has just blinked out of existence. It doesn't exist anymore. They don't understand that it's just hidden behind whatever. As they get older, they start to develop that awareness that things continue to exist even when you can't see them. And we call that object permanence. Yes. Yeah, yes. They totally fall for it. Idiots. Oh, just kidding. Yeah, that's just their normal, completely reasonable reaction given their lack of development so far. So yeah. They also, so by around, again, age 2, they're starting to develop some like symbolic representation, and they can start to understand that. So things like numbers and letters, they can at least start to grasp, even if they can't read necessarily, they can start to understand that symbols have meaning. So they're getting a little bit of that like abstract reasoning going on at the very end of the sensory motor stage. All right.